can we actually prove that the square root of 2 plus the square root of 3 equals pi? Today, let's try two methods. The first is the perimeter method, and the second is the area method. Let's look at the first diagram. The red shape is a circle, and let's assume its radius is 1 for easier calculation. On the outside, there's a circumscribed regular hexagon, and inside there's an inscribed square. Now, let's look at the square and divide it evenly into 4 parts. Dividing it evenly into 4 parts, 360 divided by 4 means each angle is 90 degrees. The short side here is the radius of the circle, which is 1, right? In an isosceles right triangle, the hypotenuse is 1 plus 1. Then, taking the square root gives us root 2. There are 4 short sides, so the perimeter of the square is 4 times root 2. Next, let's look at how to calculate the perimeter of a circumscribed hexagon. Divide it evenly into 6 parts. What is the angle of each segment? 360 divided by 6 is 60 degrees. It's an isosceles triangle, so one of the angles is 60 degrees, making it an equilateral triangle. The height is the radius of the circle, which is 1, right? The radius is 1. Suppose the length of the hypotenuse is x, then here it's x over 2. According to the Pythagorean theorem, x squared minus x squared divided by 4 equals 1. So 3/4 of x squared equals 1. So x squared equals 4/3. Therefore, x equals the square root of 4/3. Okay, so what is the length of its side? Each side is the square root of 4/3. How many sides are there? There are 6 sides in a hexagon. If we multiply by 6, we get its perimeter. The square root of 4/3 times 6, after rationalizing, is 4 times the square root of 3 divided by 3 multiplied by 6. After calculating, that's 4 times 6, which is 24. So it's 24 times the square root of 3 divided by 3. This is for the circumscribed hexagon, and that's its perimeter. Let's take their average, 4 times the square root of 2 plus 4 times the square root of 3. What is this approximately as an average? Because for the circle, its circumference lies between these two values. The circumference of the circle is 2 pi. Since the diameter is 1, it's just 2 pi. Now let's divide it by 2. We need to divide by 2 to get the average. So after dividing by 2, it's 2 times the square root of 2 plus 2 times the square root of 3, which is approximately equal to 2 pi. At the same time, if we divide both sides by the square root of 2 plus the square root of 3, we get approximately pi. This is the first method. Next, let's look at the area method. For the area, just now we calculated that its side length is the square root of 2/3. So how do we calculate its area? Isn't the area equal to base times height divided by 2, with the height being the radius, which is 1? The square root of 2/3 times 1 and then divided by 2 is the same as multiplying by 1/2. This is the area of one triangle. How many are there? There are 6. So multiply by 6 to get the area of the circumscribed hexagon. Let's simplify this a bit. Here it's the square root of 3 over 3 times 6, which equals what? The square root of 3 over 3 times 6. And after simplifying, it's 2 times the square root of 3. So the area of the circumscribed hexagon is 2 times the square root of 3. Next, let's take a look. Originally, it was a square. If we turn the square into a regular octagon, it gets even closer to a circle, right? Then divide it evenly into 8 parts. Each part is equal, so the sides are all the same, and the length of each side is the radius of the circle. Let's assume it's 1. What is the angle between them? 360 divided by 8 is 45 degrees. That's clear, right? At 45 degrees, we can calculate the height. The height is the hypotenuse times sine 45 degrees, right? That's the height. If we then multiply by the base, which is 1, and divide by 2, multiplying by 1/2, we get the area. Square root of 2 over 2 times 1/2 equals square root of 2 over 4. Its area is square root of 2 over 4. How many are there? There are 8. Square root of 2 over 4 times 8 equals 2 times the square root of 2. Okay, so its area is 2 times the square root of 2. This is example 7. This is the regular octagon. For the regular octagon, its area is 2 times the square root of 2. Y cut. For the hexagon, its area is 2b times the square root of 3. So if we take their average, isn't it approximately equal to the area of a circle? The area of a circle is pi r squared. If r squared is 1, then it's just 1. So after a month, isn't square root of 2 plus square root of 3 approximately equal to pi? Both of these methods prove that square root of 2 plus square root of 3 is approximately equal to pi.